All right, so let's solve these problems using integration by substitution method. Question 1 says, evaluate the integral of 2x exponential x squared minus 5 dx. Our first task is to identify our u, and most times u is the complex term. So let u equals x squared minus 5. X squared minus 5. If you differentiate u with respect to x, you would have, if you differentiate x squared, you would have 2x. And then if you differentiate 5, since 5 is a constant, it is 0. So our next task is to find du. So du equals 2x dx. We got this by cross multiplying. If you cross multiply, you would have du as 2x dx. So dx becomes du all over 2x. Now our next task is to substitute into equation 1. This is equation 1. Equation 1 here is 2x exponential s squared minus 5 dx. So if you substitute into equation 1, you would have 2x multiplied by exponential u multiplied by du all over 2x. Remember, x squared minus 5 is u, and then dx from our calculation gave us du all over 2x. That's why we have 2x exponential u multiplied by du all over 2x. So here we have similar terms. Let's cancel out. We have here 2x and we have 2x. So we are left with integral of exponential u du. And if you integrate exponential u, you would have exponential u plus c. So our next task here is to substitute the value of u, where u is s squared minus 5. So if you substitute the value of u, you would have exponential x squared minus 5 plus c. So this is our final answer. All right, let's solve the second problem. It says, evaluate the integral of exponential cos x multiplied by sin x dx. So which one is our most complex term? Our most complex term here is exponential cos x. So let u be cos s. So du dx becomes, if you differentiate cos x with respect to x, it will give you negative sin x. So if you simplify further, you will have du equals negative sin x dx. We got du by cross multiplying. If you cross multiply from here, you would have negative sine x multiplied by dx equals du. So that's why du is negative sine x dx. So now let's find dx. Dx becomes du divided by negative sine x. So our next task is to substitute into equation 1. And equation 1 is exponential cos x multiplied by sine x dx, where u equals cos x and dx from our calculation is du all over negative sine x. So if we substitute, we would have integral of exponential u multiplied by sine x multiplied by du all over negative sine x. So here sine x into itself is 1, and then sine x into sine x is 1, so they cancel out. So we are left with integral of negative exponential u du, which can be written as integral of negative 1 multiplied by exponential u du. So our next task is to bring out the constant term, which is negative 1. So here we have negative 1 exponential u du. So we have negative 1 open bracket. If you integrate exponential u, it will give you exponential u, and then plus c. So if we simplify further, we would have negative exponential u plus c. Now let's substitute the value of u. Remember, u is cos x. So if you substitute the value of u, you would have negative exponential cos x plus c. So this is our final answer, where c is the constant of integration.